Black holes are like omnivores. They'll eat anything in their way if it gets close enough, including planets, stars, clouds of gas, or some very unfortunate intergalactic travelers. Not that it really gets hungry and goes after space objects, it simply swallows whatever comes nearby. It stretches giant space bodies until they're thin, like spaghetti, and rips them apart atom by atom. A black hole is a huge amount of matter that comes in a very small package. It's like you squeeze a star 10 times bigger and more massive than the sun into a small area with the diameter of New York City. You get an extremely massive, compact, and dense pit with gravity so strong, not even light can escape, not even another black hole. They don't have a fixed point in space. Stars, planets, asteroids, comets, black holes, and everything in the universe is in constant motion. That's why things get so chaotic from time to time. Researchers found a giant black hole at the heart of one galaxy being eaten by an even bigger one. A black hole can get extremely big. At the centers of most giant galaxies are black holes that can grow millions to billions of times the mass of our sun. One of the ways to become so big is by eating others of its kind. A black hole merging with another black hole is one of the most energetic and powerful things in the universe. Picture this: 1.3 billion years ago, two black holes are circling around each other. The bigger one pulls the smaller black hole inwards, and now they're locked together in a spiral. Through time, that orbit starts decaying, but very, very slowly. These two black holes are constantly getting closer and closer. As they approach one another, the disks of orbiting dust and gases that surround them mix and create an intense towering vortex. It extends and goes pretty high above the center of that disk. At some point, they finally merge into one extra big, supermassive black hole. As they're merging, they kick out gravitational waves. These waves tell us a lot about black holes, but they can't reveal their precise position. So, scientists need some electromagnetic signal that will find the black hole's location, like radio waves, X-rays, or a flash of light. We can't see black holes, but we can detect their effect on space objects that are surrounding them. When a black hole passes through a cloud of matter, its strong gravity will pull matter inward. If a star or a planet comes close enough, the same will happen. The attracted matter then accelerates, which means starts to move very quickly and heats up. The black hole then starts emitting X-rays that radiate in the area surrounding it. The energy of X-rays affects the neighborhood and can, for example, spur the growth of new stars. And finally, bam! They collide. It's a massive burst of energy, one of the biggest bangs ever since the Big Bang. In less than a second, that collision emitted more energy than all of the stars in the visible universe together at the same time. Black holes can become huge, but not necessarily. Stellar mass black holes have a mass similar to the Sun, and they can be very small. The one scientists found in 2019 is located 10,000 light-years away from us and is only 12 miles across. They really have a reputation for destruction, but black holes are just another source of gravitational force, similar to stars. That means it's possible for a space body to orbit them, if it moves fast enough, of course. Let's say there's a black hole with the same mass as the Sun. The speed a space body would have to move at is the same as the one needed to orbit our Sun, if the distance is the same. That's a theory. In reality, planets don't really orbit black holes, because those that have a mass similar to our parent star are mostly the remnants of giant stars that ran out of nuclear fuel and eventually exploded. That's how black holes are created in the first place. And chances are that none of those planets nearby will survive it. But 30 years ago, scientists discovered the first planets beyond our solar system. These planets were found orbiting a pulsar, which is also some sort of supernova remnant. We don't know how they survived the explosion of their parent star. It's possible they may have been created after the destruction from debris that formed after the explosion. Scientists even have a theory that black holes are possibly wormholes, something like tunnels to other galaxies. That means they don't destroy objects they swallow, but send them somewhere. The theory says the object that enters and then goes out on the other side leaves the tunnel through something opposite of the black hole, a white hole. It probably looks similar to its companion, with all that spinning and similar mass. There could be a ring of gas and dust around the event horizon. The event horizon is the point of no return, the part of a black hole where nothing escapes. Unlike a black hole, a white hole lets light and all the matter leave, but none of that will be able to enter the portal once again. About 50 years ago, Stephen Hawking realized that black holes leak energy. Scientists then developed the theory that a white hole could be born out of a black hole. They're still not sure how the black hole disappears, but in this scenario, it would grow so small it no longer can have such strong gravity that makes it swallow other objects. So, it might turn into a white hole then. Such a hole would be similar in mass to something really light, like human hair. It wouldn't be so dramatic as its black hole ancestor, but it would still hide mysteries in its interior, the information of all space objects it had swallowed previously. It would eventually spit out that information and get so big, it would dominate the universe. White hole behavior, opposite of black holes and all that sucking the matter inward, could be compared to the Big Bang explosion, where the universe is expanding and new objects are forming. But even if something like this happens, it may only be possible trillions of years from now. And there's an issue. Even if some big white holes did form somewhere in space, they probably wouldn't last too long. Outgoing objects would collide with the matter in orbit, so the whole system would collapse and turn into a black hole once again, since they're also formed after supernova explosions. Stars, asteroids, comets, galaxies, and planets, all those space things we can see, make up nearly 5% of the universe. About 25% could be dark matter, a mysterious substance we can't actually see, but assume it's there because everything in the universe moves to its gravitational tune. This dark matter is kind of like a spider's web. It holds all those galaxies that move pretty fast together. Its evil twin is called antimatter. Antimatter particles are like the opposite version of the matter, the same mass but opposite electric charge. When they collide, antimatter wipes out the regular matter, and the result is pure energy. Dark matter probably makes the universe expand even faster than it used to do. One of the latest theories says it could be responsible for the huge asteroid strike that made the dinosaurs go extinct, too. The universe doesn't have a center, but galaxies do. The Earth makes a circle around the center of the Milky Way once every 250 million years. This orbit is not straightforward, but we can roughly predict it. Once in every 60 million years, we go through the crowded region of our galaxy, known as the galactic disk. At the same time, we can track some harsh mass extinctions in the history of our planet, including the asteroid that wiped out the dinosaurs about 66 million years ago. Professor Rampino from New York University proposes that dark matter has a gravity that could throw nearby space bodies into the Earth's path whenever we enter the galactic disk. That means some asteroids and comets that would usually be far away from us are flung towards our planet. The biggest thing in the universe, at least the one we know about, is the Hercules Corona Borealis Great Wall. It's a cluster of galaxies 10 billion light-years across, bound together by gravitational force. The biggest elliptical galaxy is IC 1101 and has a diameter of 4 million light-years. The smallest galaxy, Segway 2, we've discovered so far, has a diameter of a little bit over 220 light-years. It's pretty faint and has only 1,000 stars. For comparison, our galaxy has 100,000 million stars. It orbits the Milky Way.
Black holes are some of the most enigmatic and sinister phenomenon in the universe. They can swallow up entire stars and planets, bending the very fabric of space and time. But what if Earth, our home planet, were to be caught in the grip of a black hole's event horizon? What would we see before the inevitable end? Well, let's have a look-see, okie dokie. So a black hole is like the bully on the playground. You avoid them at all costs. It's a region of space where gravity is so strong that nothing, not even light, can escape it. It's like Houdini in reverse. As with snowflakes, every black hole is unique. Each one has its own mass, spin, and charge. And they also come in different sizes, sort of like jeans. Petite, slim, regular, and husky, or something. Anyway, there are 4 sizes. The smallest black holes are the stellar mass kind. They're born when the massive star runs out of juice and folds in on itself. They're like the chihuahuas of the black hole world. They may be tiny, but they're feisty. They gobble up nearby matter like a hungry puppy. And even the smallest one is 3 times more massive than our Sun. Next up, we have the middle children of this cosmic family, intermediate mass black holes. They're too big to be born out of collapsed stars. Scientists believe that they may be created when several black holes merge into one. And even though they can't dominate galaxies, at least they can swallow up some nearby stars. Goody for them, huh? But do you know who can dominate a galaxy? The enormous monsters of our universe, supermassive black holes. They're the giants with masses ranging from millions to billions of times that of our Sun. And they play a crucial role in the growth and formation of their host galaxies. Finally, there are ultra-massive black holes. Trust me, you can't even imagine the size and mass of these guys. These cosmic eldritch horrors are extremely rare, but the ones we know can devour entire galaxies like Pac-Man. So, what happens if you get too close to a black hole? Or more like, what would you see in your last moments? Well, first, you reach an event horizon. It's like a point of no return, an invisible boundary that marks the edge of a black hole. And here's where things start to get really weird. For example, time starts to slow down. Not for you, for an outsider watching you from a safe distance. If you were falling into a black hole, you wouldn't feel any different. But if you were watching someone else fall into it, you'd see them slow down and eventually freeze in time, like in a paused video. As you get even closer, you would start to see some pretty mind-bending things. The gravity would cause the light around you to bend and distort, creating a sort of funhouse mirror effect. You might even see a halo of light around the black hole, known as the photon ring, or jets of high-energy particles spewing out from the black hole's poles. You can actually get pretty close to a black hole without feeling any major effects. It's only when you cross the event horizon that there's no going back. Your goose is cooked. After crossing this boundary, you'd be unable to see anything. For the person watching you from the outside, it would be as if you had suddenly disappeared. Meanwhile, you might start feeling a bit stretched out, like a piece of spaghetti. This is because the gravity is so stark that it's pulling you in different directions at once. There's even a scientific term for it, called spaghettification. We'll cover linguinification in another video. Now that you're inside a black hole, you're taking aim at the singularity. It's a point of infinite density in its center, where all matter is crushed down to a single point. It's like trying to fit an elephant into a tiny matchbox. Everything gets squished together until it's as small as it can possibly be. Which means it's time to wave goodbye, I guess. And if all that sounds scary, here's another fun fact. Black holes are not rare at all. Actually, there's one in the center of each galaxy, including our own Milky Way. So, does it mean that we'll eventually be sucked into it? And if so, how exactly would it happen? Well, let's see. Imagine a black hole approaching our solar system. At first, it appears as nothing more than a tiny speck in the distance. But as it gets closer and closer, its gravitational pull begins to wreak havoc around. Planets start to veer off course, asteroids are flung into oblivion, and comets are shattered into a million pieces. But just like waiting for the sausage to be served in a German restaurant, the worst is yet to come. Yeah, like that joke. Soon, it inevitably reaches the Earth. First, our planet's atmosphere would be pulled toward the black hole, triggering a massive windstorm. And there'd be huge waves on the oceans, the water itself being distorted by gravitational forces. Imagine seeing seas and oceans getting stretched out. Earth's magnetic field is generated by the motion of molten iron in the planet's core. But now, the extreme tidal forces of the black hole would disrupt this motion, causing the magnetic field to weaken and distort. All this would cause massive earthquakes and volcanic eruptions as the planet's crust and mantle were pulled apart. All infrastructure and technology would be completely destroyed. Buildings, bridges, and roads would be torn apart. Okay, let's hit the pause button. Pretty horrifying, isn't it? Nah, but don't worry. You wouldn't have even seen that much, because you would have felt the effects of the black hole much, much earlier. Well, back to the future. We'll lose our magnetic field even before everything started to collapse. And this means not only that the weather and climate will become terrible, we'll also be exposed to extreme radiation. These gamma rays and the heat from the black hole could drastically change our planet. Say ta-ta to all our beautiful nature. At least misery loves company. We won't be the only ones affected by a black hole, which is probably even worse. As this beast engulfed the entire solar system, it would consume about everything. One immediate effect would be the disruption of the orbits of asteroids, comets, and all the other bodies. The planets would begin to deform and stretch, their surfaces warping like molten metal. The sun itself would be affected, its surface contorting like a glob of putty. And yeah, all this is scary even to imagine. But now, breathe and relax, because none of this will ever happen. This is the bright side, remember? Your infinitesimal odds of winning the big lottery are even better than the Earth ever being swept into a black hole. The nearest black hole to our solar system is called Gaia BH1. Discovered by scientists in 2022, it's found in our own Milky Way galaxy, about 1,600 light-years away from Earth. Gaia BH1 is about 10 times the mass of our Sun, which makes it a stellar mass black hole. It's not very interesting on its own, but its discovery has supplied valuable insights into the behavior of these cosmic monsters. But as you can see, even the closest known black hole is over 1,000 light-years away. They move very slowly, and they'll never get so close to our system to pose some kind of a threat. Hey, but didn't you say there's a black hole in the center of the Milky Way galaxy? Doesn't that mean it's going to eventually hoover up our entire galaxy, you may ask? Maybe not in that voice. Well, don't worry. The correct answer is no. The one in the center of our galaxy is called Sagittarius A star. You may remember it from that viral blurry photo that circled around the internet a few years ago. This black hole is indeed very massive and has a strong gravitational pull, like two 8th graders in love. However, it's still a small beam. It only affects objects that are close to it. The objects in the galaxy are all too big and move too fast to be pulled in by black holes. Nevertheless, they're still fascinating objects to study. Scientists are still trying to unlock the mysteries of black holes. And even though they'll never be dangerous to us, they're still a huge reminder of the incredible power of our universe. Now really, an object weighing billions of times the mass of our Sun must be easy to find, right? Wrong. Unfortunately, it might not be that simple, like in the case with a missing black hole. But let's travel to the galaxy cluster Abell 2261, hosting a supermassive black hole at its center. Or at least, that's where it's supposed to be. The main problem is this giant space phenomenon is nowhere to be found. Now, supermassive black holes are mega monsters, churning slowly at the center of their home galaxies. They gather tremendous clouds of gas and dust around them, which makes them swell up to sizes the human mind can't begin to imagine. If a supermassive black hole, like the one that dwells at the center of our home Milky Way galaxy, moved even a little bit closer to our solar system, we'd be doomed. The distance between this huge thing and Earth could be several dozens of light years, and still, it would wreak havoc on our planet. Earth, along with other things making up the solar system, would be tugged into the black hole's orbit and doomed to spin around it for eternity or longer. Hey, who knows, right? So, it's good that such black holes stay away from us at the moment. So, let's see what happened to that runaway supermassive black hole from that gigantic cluster of galaxies around 2.7 billion years away from our planet. Scientists have been looking for it with the help of NASA's Chandra X-ray Observatory and Hubble Space Telescope. But so far, no result. The main problem with finding a black hole is that it's, black. And space is, you guessed it, black too. So there's no contrast whatsoever that could help astronomers spot the hole. But scientists haven't given up yet. After all, they have a lot of other technologies to find black holes, small and big, in the vastness of space. Some of these methods involve watching the stars orbiting black holes. Sometimes it's a fake gravitational wave signal, which is produced when two black holes collide. But the most reliable technique is watching dust and gas falling to their doom. The thing is, black holes are space objects with insane gravity. So regions of space surrounding them are usually a bit chaotic, gas and dust getting pulled into the bottomless abyss, compressing and heating up. In the process, it releases a flood of X-ray radiation. So, astronomers look for extremely bright X-ray sources in the universe. Chances are those are the last gasps of giant clumps of material before they disappear into a black hole. Then, why can't scientists find such X-ray signatures left by the black hole in Abell 2261? One of the most mysterious things about its disappearance is that radio telescopes have spotted some signs of massive plumes of superheated material launched at one point within the last 50 million years. These plumes were most likely caused by a large black hole, which is nowhere to be found these days. So, at the moment, we can only play a guessing game. Maybe two medium-sized black holes collided, pushing the newly merged giant out of the center of the galaxy. The observations of the stars in that galaxy have shown a clump of dense material a few thousand light-years away from the galaxy's core. Maybe it's the runaway black hole, but disappointingly, no X-ray signals are coming from that clump. Or the hole might still be there in its rightful place, but it's, slumbering. If it doesn't get a fresh supply of gas and dust, it has nothing to feed on. As a result, it can't release a flood of X-rays. But again, the answer, do not disturb, the black hole is sleeping now, isn't very satisfying. Why isn't it getting its space food? What happened 50 million years ago? What is that clump of material speeding away from the galaxy center? So many questions, and no answers so far. At least, we know what black holes look like. Well, kinda. It's actually the shadow of a black hole's event horizon, visible against the glowing superheated material falling inside the hole. The first ever mugshot of a black hole appeared in 2019, but the data for its creation was collected in 2017. It took an international team consisting of more than 200 astronomers 2 years to assemble the image. We can admire this amazing space phenomenon thanks to a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. Why such a name? The thing is that the event horizon is a point of no return on the outskirts of a black hole. When something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape the black hole's clutches. Anyway, to capture that very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 powerful radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. Plus, to keep the chances of rain and bad weather to a minimum, they even constructed the telescopes in super dry regions, such as the Atacama Desert in Chile and the South Pole. On each observation day, the telescope gathers roughly 350 terabytes of data. That's 10 times the amount of data collected every day at the Large Hadron Collider. But let's speak more about black holes themselves. There are stellar black holes, smaller but even more dangerous than their supermassive peers. They appear when stars that have run out of their star food fall into themselves. If a star used to be big enough, it keeps compressing and compressing some more, and voila! A baby stellar black hole is born. But even if I call such a hole a small one, it's still 5 to several tens of times heavier than the Sun. Unlike their massive siblings, Hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have the mass of 1,000 SUVs. One theory claims tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple mini black holes pass through our planet every day. There is a supermassive black hole smack dab in the middle of our galaxy, the Milky Way. Its name is Sagittarius A star, and it's 4.3 million times as heavy as the Sun. And nope, we aren't going to be pulled into this hole. It's more than 26,000 light-years from Earth, too far to have any influence on our planet. By the way, recently, astronomers have discovered that this supermassive black hole might be leaking. If it's true, it probably means that Sagittarius A star isn't a sleeping giant, as previously thought. It might still be active. And the leakage recorded by scientists may be the hole hiccuping while swallowing clouds of gas. Maybe we should burp this baby? If you ever find yourself near a black hole, get ready that time will significantly slow down. It may work for you if you aren't eager to grow older. Just don't let yourself be tugged beyond the point of no return. Another danger of hanging around a black hole is that it might start behaving like a massive galactic volcano. From time to time, black holes flare up, but instead of spewing lava, they produce enormous amounts of energy, and it makes gaping holes in the surrounding material and gas. A short time ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light-years away from Earth. The crater left behind, which was actually a hole punched in the cluster's hot gas, could fit 15 Milky Way galaxies. Okay, mind blown, I'm out of here.